So we just completed the pilot study now on this project that's done at University of New England in collaboration with Rob and Hal at RMIT. So why to look into that? So at the moment, the gut health monitoring in commercial flocks is based on gut growth pathology, looking at general lesions, signs of inflammation, digestion of the intestinal content. Some farms, they have a proxy monitoring program, which they look at score the intestines for the different coccidia species, and also necrotic enteritis. But everyone that has seen those cases know that you can have mixed infections, and it can be quite tricky to do the score of these lesions. So it requires skilled staff, as it can be highly subjective, and it has no predicted value. So once you see the lesions, you already have the problem going on. And it also requires terminal sampling of birds, which is undesirable, especially if you have breeder flocks. On top of these gut lesions, you have other indicators that can be used to look at general gut health, such as wet litter and production data. But those factors, those indicators are influenced by many other things, and they are not specific to gut health. So because of that, there are lots of biomarkers that are under investigation all over the world in many labs, and Reza did a great job in explaining the tight junctions of the intestinal epithelium. That's what you expect when you have a healthy gut. And the opening of these tight junctions when there is any pathology. So the majority of the biomarkers to look into gut health, they are either looking for bird metabolites, so plasma proteins and proteins from these epithelial intestinal cells that go into the intestinal lumen and get into feces and litter samples, or these bacterial metabolites, or the whole bacteria that come and leaks from the gut and goes into the blood and the liver. There is a third tool that can be used to look more broadly at gut health, that's not looking at the gut lining as the previous markers, but it's looking at the microbiota patterns using sequencing. So it's descriptive. It doesn't say if there's permeability in the gut. It just says that, but there's plenty of research showing that certain patterns of bacteria, they are more favorable and related to high production, and other patterns are less desirable and linked to lower production. So at the moment, there is nothing available that will tell you general gut health status. There are some limitations on what is available now. So some of those biomarkers, and Reza was talking about some of them on his presentation. They will vary depending on the leaky gut model that was used. So we probably will need a panel of those markers. There are also some issues with stability of them, especially if you're looking into feces and litter to do this check. And very important as well, there is a very high variability in the response of individual birds on these biomarkers. So you can find sometimes both diseased and your healthy birds with the same levels of the biomarker, which creates some issues on interpretation of the results. And of course, price is a big important factor to consider when you are looking at on-farm diagnostics. So our research question was, based if those biomarkers are to be used in commercial flocks, we should probably be looking at population level samples and the population level health, as the treatment on flocks are for the whole flock and the whole farm, and not for individual birds. So with this in mind, we want to see if if we would test pooled feces and dust, looking at microbiota disruptors such as Clostridium perfringens that cause necrotic enteritis, and several species of coccidia by PCR tests, and also looking at microbiota patterns in these pooled feces and dust. And if we could relate what we are seeing on these patterns with the performance in commercial flocks. So we first looked into experimental flocks, and these are necrotic enteritis models that were conducted here at UNE by Shubiel Wu lab. So here is the profile for Eimeria cervulina, brunetti, and maxima in dust. So pooled feces have been used to detect coccidia for a very long time. We just want to see on this study if we could find different profiles in flocks with subclinical necrotic enteritis and clinical necrotic enteritis, and we could see some differences. We also did a pilot study looking at the different microbiota profiles in these population level samples, such as looking at litter and feces and dust, and we could find some signature, but we were unsure on how it would relate to commercial flocks. So the next step was to do a pilot study, and we looked in 8 farms. So we approached 2 integrator companies, and we followed 4 farms that were consistently high ranked in terms of productivity within the company, and 4 farms that were low ranked. We collected dust samples that using these funnels that would just hang on these vertical wires in the shed, and pooled feces from different locations of shed. We look at 2 sheds per farm, and we asked them to collect samples every week until day 35 of the cycle. So what we found was, here you can see the plots for the detection of Eimeria cervulina, and at the bottom the Eimeria maxima. So here are the levels. These are just DNA detection of those pathogens. So each line represents 1 farm, and the solid lines are top-ranked farms, and the dashed lines are low-ranked farms. So in summary, all of those flocks were positive for both Eimeria cervulina and maxima. And for cervulina, we found a peak of detection around day 21 and 28 of the cycle, and then a decrease, probably due to build-up of immunity. The profiles for Eimeria maxima were a little bit more varied, and there is no pattern. If they were high ranked, we have both a tendency to decrease after day 28 until day 35, a decrease on the load. And some of these high producing farms continue increasing over this 30-day mark, when we stop looking to that. We could not find, we didn't find Tenella and Necatrix in any of the 8 flocks we looked, and there was only 1 farm that was positive for Brunetti at the end of the cycle. So based on that, the detection levels were not related to performance. There was no evident link. Probably because the levels that we looked here were low if you consider the standard when for the oocyst count per gram of feces, which was around this threshold to be at low risk. for coccidiosis. When we looked at Clostridium perfringens detection as a proxy for necrotic enteritis, we found very low levels of Clostridium, which we're expecting to find in the majority of the farms. We're expecting to find a little bit of a higher detection rate. There was only one farm that was top ranked that was positive for Clostridium perfringens, and that was the only farm that was positive for net B toxin. So we know that net B toxin is a predisposing factor and considered to give virulence to these Clostridium perfringens strains. But the vet said to us that there was nothing, no gut symptom or clinical sign related on this block. So it was interesting. Again, no clear relationship of detection level and performance. When we looked at the microbiota profiles in dust and pooled feces, here is the overview. So these are company A and B. Each one of those dots represents one sample. The closer the dots are, the more similar is this microbiota profile. The more distant, the more dissimilar. So as you can see here on the plot for company, the highest variation we had on the data set was related to company. So company A here is in yellow, and you can see a clear differentiation on the profiles from company B here in blue. And there was a bigger difference than what we looked when we looked at the data on high versus low performance among those flocks. Despite this overlap that you can see here, we could still find some bacteria, some different genera of bacteria that they were much more prevalent on low producing flocks compared to the high producing flocks. We are sampling an additional 30 farms, which include the third company, so we can further investigate these differences on the microbiota profile between the different farms. And yeah. So the key findings from this pilot study we've done so far is that both pooled feces and dust could be used to detect these Coccidia, Clostridium, and looked at microbiota signatures. The feedback we had from the veterinarians and the farmers was that dust was far more convenient to collect, and we are doing the second phase of the project using dust only. There are some issues on transport and keeping the cold chain for the fecal samples as well. So the levels of Coccidia and Clostridium were similar in high and low ranked farms, but overall the Coccidia levels were low in all study flocks. So all of them were on coccidial drugs and none of them vaccinated for Clostridium. Sorry, for Coccidium. And it was interesting to see the Clostridium net be detected in one high ranked farm, but no relationship with clinical signs for necrotic enteritis. There is some evidence of differential microbial pattern in high and low ranked farms, and we are looking forward for the second phase of the project, that we can see if the markers that we found before will be replicated on this second phase. So that was all for me. Thank you.